All right, today what we're going to be doing is talking about transformations on absolute value functions. So the absolute value function is this function right here known as f of x equals the absolute value of x. Now what would that look like? Here we go. I've typed it in. F of x equals the absolute value of x. So you can see what the graph looks like. You can see that it from 0, 0, it just goes up 1, over 1, up 1, over 1, up 1, over 1. Now what we're going to do is we're going to transform this to different places. So here's what we're going to talk about. All right. First thing we're going to talk about is what happens if I do f of x and let's say I add 3 to it. Now, if f of x equals the absolute value of x, then I would basically say that means the absolute value of x plus 3. So whenever I say f of x, I want you to think of it as being the absolute value of x. All right? So if I say, what would happen to the graph if I just add 3 units to it? That is going to it either shifts, you could say the word shifts, or you could say translates this graph up 3 units. Now, this function, the absolute value function, this is what's called, this is the parent function. All right? That's the parent function for all absolute value functions. Now, if Samuel L. Jackson was the math teacher here, he would probably call that a mother function. All right, but we call this the parent function for all absolute value functions. Did I just say that? Yes, I did, didn't I? Oh well, nobody's going to listen to this anyway, so here we go. Let's see if that works. Ready? If I say the absolute value, ready? If I say what's f of x, put f of x, and put what? Plus 3. Look what happens. What happened between the two graphs? From the orange to the green. It went up 3 units. You can see it right there, up 3 units. Now remember what I told you guys about f of x equaling the absolute value of x? So I'm going to go ahead and delete that and make sure you guys see that that simply still means the absolute value of x. You're like, whoa, 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 what happened? Hold on. That's going to be our next concept. Let's kind of focus on this one first. There we go. So if I say plus 3, it's going to go up 3. Well, what do you think is going to happen if I say f of x and I put minus 4, which would be basically mean the absolute value of x minus 4? Well, that still shifts the graph or translates. But this time we're going to say down 4 units. So this deals with up and down. What happens if I say f of x and I put minus let's say 5 like that? Which basically means we're taking the absolute value of x and we're taking away 5 on the inside of the absolute value bars. Well, you know what? It's still dealing with shifting or translating, but shifts. I'm going to put translates. Translates. It's going to be 5 units. I wonder which direction it's going to go. It's going to be 5 units to the right. And you're like, I think you're wrong. I think you're going to be wrong on this one. I can totally understand why you think I might be wrong. Okay, so here we go. Look what happens when I put f of x minus 5. Where does it go? It goes 5 units to the right. Now remember what I said. This still means the absolute value of x minus 5. So does everybody understand the green, where I say f of x minus 5, and the absolute value of x minus 5? These mean the same thing. Why do they mean the same thing? Because I've defined f of x being the absolute value of x. So that's why these are the same. So that went 5 units to the right. So how can you figure out whether it's going to go to the right or to the left? So here's what I'd like you to do. I'm going to highlight this section on the inside of the absolute value bars right here. And I want you to put a little arrow here, and you're going to say set this equal to 0. And you're like, what the heck are you talking about? Set what equal to 0? That equation. All right, okay, I'll do it. Fine. All right, x minus 5 equals 0. Now solve for x. What will we do to both sides? Add 5, right? And we get x equals 5. So basically you're looking for what number would you plug in here to make it equal to 0. If that number is a positive, you know it's going to be going to the right. If that number ends up being a negative, you know it's going to be going to the left. So that's how I know it's 5 units. It's 5 to the right. So let me give you another example here. Ready? A little down here, a little bit lower. If I said x plus 7, which basically means the absolute value of x plus 7. Well, if we just learned that x minus 5, or the absolute value of x minus 5 shifts 5 units to the right, then following this pattern, it's going to shift, or it's going to translate 7 units, what direction? Left. You're like, I don't believe you. Well, I told you, and after I tell you, now I'm going to show you. Here we go. So watch what happens here. I'm going to take that away and put plus a 7. Then over here, I'm going to take that away, put plus a 7. And hopefully you'll see these mean the same thing. And what happened? It went from what? 0, 0 to where? Negative 7, 0. Can you guys see how that's 7 units to the left? All right, so now go back. So now you know these statements are true. Whenever I'm doing a video, I will tell you and then I will show you. Okay? All right, so we are done with all of the shifting and the translating. So in review, all right, if I go right over here, and let's say I just put f of x right here. Oh, that's too much. That's just too big. Sorry. And I put f of x plus 2. What happens? It goes up 2 units, right? If I said minus 2, it goes down 2 units. But if I go over here and put minus 2, it goes to the right 2 units. But if I go over here and put plus 2, it goes to the left 2 units. So that's kind of a quick little review. You can rewind and see that again if you want to, but I'm not going to go over that again. Now we're going to go over something more awesome, and it's dealing with reflections. Now I'm not going to tell you what negative f of x does, but hopefully you can see what negative f of x does, because now we're going to go over to our next section dealing with reflections. So right here, I'm going to title it Reflections. All right, there we go. Titling it Oh, hold on there. There we go. Slide it right over here. All right, so here we go. Reflections. Now, if our parent function, which is f of x, equals the absolute value of x, what happens if I made it negative f of x, which basically becomes what? Negative absolute value of x. What would you guys describe this as? It's reflected across something. Let's see here. What would you guys say? Yeah, I hear you. So right here, negative f of x, what does it do? It reflects across the x axis. So this is very, 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 very important. You have to know that if you have a negative on the outside of your function and you multiply everything by a negative, it's going to reflect across the x-axis. So let's make a really awesome function here, all right? So I'm going to call this, I'm going to call f of x this. Ready? F of x equals the absolute value of x plus 2, we'll say minus a 5, okay? So what would negative f of x actually become? Well, if I take a negative and I multiply it to this absolute value, that becomes negative times the absolute value of x plus 2. But what's a negative times a negative? It becomes a positive. So if I said f of x was this, negative f of x would equal this. So this is kind of a good example, all right? So what happened to this graph? It shifted 2 units to the left and 5 units down. So we're going to go ahead and type this into Desmos. All right, I'm going to type it into Desmos. So I'm going to pretend f of x, I'm going to delete this real quick so we don't see it. F of x equals x plus 2, which made it go 2 units to the left, right? And I put minus 5, which means it goes down 5 units. So you can kind of see that. Now look what happens when I type in negative f of x. What? That is so cool. It reflects across what? The x. Can you guys see how that reflects across the x-axis there? All right. Now, what did I say that actual function was equal to? I said it was equal to negative absolute value of x plus 2. But what did I say happened to this negative 5? If we multiply a negative times a negative, it equals a positive. Hey, look, the green and the purple are the exact same function. Huh? Kind of cool, huh? All right, reflects across the x-axis. All right, I mean, it's not like Star Wars cool, but, you know, this kind of resemble a TIE fighter almost. You know, you kind of see the TIE fighter in there. All right, so what do I want you guys to write down? Negative f of x does what? Reflects across the x-axis. Okay, I wonder if there was a f of negative x. Well, like, what would that do? Like, if negative f of x reflects across the x-axis, I wonder what f of negative x does. Well, it does some reflecting. I'll let you know. It does some reflection. It reflects across, wait for it. What do you think? Heck yeah, man. Across the y-axis. All right, so let's say f of x still equaled the absolute value of x plus 2 minus a 5. Like, what would f of negative x look like? So check this out. This is what your new function would look like. Ready? If I take all my x's and make them negative, all right? I don't know about you all, but sometimes x's can be negative sometimes, all right? All right, so you put a negative x plus 2 minus 5. Wait a second. You didn't change anything. What's the only thing that I changed? Right? I just changed the what? I changed the x and made it what? Negative. That's all I did. Okay? So, everybody, this is what I want you to understand. These are going to be reflections across the y-axis. And I'm going to prove it. I'm going to prove it to you. Okay? I'm going to prove it to you. I'm not just going to say it. All right? I'm going to prove it. All right, here we go. So, watch this. I'm going to take that negative away. All right? And then where am I going to put it? On the inside. And right now it's kind of hard to see because you got this purple graph, right? So what did I say? I took that negative away. All right? And I got to change that negative 5 back to a, sorry, that positive 5 back to a negative 5. And what do I got to stick right next to this? A negative. Bless you. Now, look at the green and the purple. What do you notice about them? They're the same, right? Can you guys see how it reflects across the y? By the way, the y-axis is at x equals 0. In case you didn't know. All right, x equals 0 is the y-axis. And in case you didn't know, y equals 0 is the x-axis. Like, wait a second. You're confusing me here. Did you just say that the x-axis is y equals 0? Yes, because what is y always equal to on the x-axis? 0. And what is x always equal to on the y-axis? 0. All right? So, this is how you reflect stuff where? Across the y-axis. All right, we're totally done right there with that one. All right, we're going to go there. Delete that. Let's go ahead and go back to our parent function. Let's go back to our mother function right there. There we go. Okay. Now we're going to talk about dilations or scaling things vertically. All right. Like, whoa, 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 whoa. What did you just say? So here we go. You guys ready? We're going to talk about, title this, ready? Dilations. Also known as scaling. All right. But more specifically, we're going to be dealing with what's called vertical dilations or vertical scaling of absolute value functions. So please write this down. This is our last concept for the day. So if you've fallen asleep already, don't worry, just keep sleeping. You'll wake up and rewatch this later. All right, so here we go. What if I were to say f of x equals the absolute value of x? That's our parent function. But what if I were to take a number, like you just put a, I know a represents a number, okay, that we don't know yet, okay? But if I said that the a value was greater than 1, then that number could say be a 2, right? Or say that number could be a 3. Now, it could be fractions, right? You could say, what if it's, like, say, the fraction like 5 over, let's do 5 over 2. Because what technically is 5 over 2? That's 2.5, right? So that's still greater than a 1, correct? So here we go. If I said a times f of x equals a times the absolute value of x, then 2 times f of x is 2 times the absolute value of x. And 3 times f of x would be 3 times the absolute value of x. You know you want to do it. And 5 over 2 times f of x would be 5 over 2 times the absolute value of x. I'm just not going to say it and make it awkward. Just kidding. So there we go. So right now, I want you guys to understand that what's happening right here, this has been scaled, or vertically, we're going to call it a vertical stretch. Vertical stretch by a factor of 2. Whew. This one is a vertical stretch. I know some of you guys are probably using ditto signs, okay, because you're like, I just don't want to feel like writing it. All right, by a factor of 3. Whew. And this one is a vertical stretch by a factor of 5 over 2, or you could say 2.5. Whew. There we go. Now we're going to, remember, I said I'm going to tell you, and then I'm going to show you what a vertical stretch looks like. All right, so now we're going to go to Desmos. Here we go. Check this out. We're going to go to Desmos. Now, watch what happens when I go 3f of x. Oh. All right, there's 3f of x. Now, here's how you can interpret it. Check this out. Oh, sorry. Do you see how the original one went up 1 and over 1 and up 1 and over 1 and up 1 and over 1? Look at 3f of x. Check this out. Watch how much it goes up. Oops. Hold on, went too high. Up and then over. And then up. I didn't do a very good job. Here we go. Up and over. Now, hopefully, if you're in Algebra 2, hopefully you've been in Algebra 1, and what does this kind of remind you guys of? Does this remind you of anything? Like rate of change? Change in y over change in x, right? So it's very similar to, basically like slope, right? Up 3 over 1, up 3 over 1. There's the change in y, there's the change in x. What we scaled it by? A factor of 3. Now, what did I say 3f of x was technically equal to, everybody? I said it was equal to what? 3 times the absolute value of x. They mean the same thing. So what happens if I put a 2 there? What happens? It goes up 2 over 1, up 2 over 1. Up 2 over 1. What about 5 over 2? No way. Are you kidding me? Does it go up 5 and over 2? Yes. Yes, it does. All right. Now somebody like, well, what about up 2.5 and over 1? Okay, we can do up 2.5 over 1. We'll try. All right, we'll try to go up 2.5 and then like over 1, but you'd have to do that twice. Up 2.5 over 1 to get there. But notice you can count 1, 2, 3, 4, 5, and over 2. Now, what do you guys notice about that graph? Oh, sorry. This graph and this graph. Are they more narrow or more wide than our original parent function that's in orange? Are they more narrow or are they more wide? More narrow, right? So what do I want you guys to do right here? All of these graphs, all of them, every single one of these graphs are going to become more narrow than the parent function. I kind of did it wrong on the bracket. Sorry about that. It's just the 2, the 3, and the 5 over 2. Sorry. All of these graphs are going to become more narrow. So make sure you guys, these are become more narrow. And we only have one more concept after this. Okay? So here we go. I'm going to draw a line in the sand. Just kidding. There we go. Now, this one is still going to be, everybody, it's still going to be a times f of x. But this time, our a value is not going to be greater than 1. It's going to be less than 1. But I'm just letting you know, we got to make it bigger than 0. So a is going to be what? Less than 1, but greater than 0. So what's going to happen? If these become more narrow, what do you think is going to happen with this over here? What's the opposite of narrow? Wide, right? Let's see if that works. Ready? Check it out. Let's make a fraction, like 1 divided by, let's see here, 1 divided by, give me a number. 5? Okay, boom. What? 50. Wait a second. Why can't we make this 0? Look what happens if you make it 0. It's totally flat, right? So it's got to be a fraction between 0 and 1. I can't make it 1 because it's the what? That's the same. These are the same. But if I suddenly I make 1 divided by 2, now you can see the width has changed. Okay? So what happens? Look, it goes up 1 over 2, up 1 over 2, up 1 over 2. So what do we call this? We don't call it a vertical stretch. All right? So if I said 1/2 f of x, that would be 1/2 the absolute value of x, and we call this a vertical shrink. Sometimes the word compression is used. Vertical shrink or vertical compression, but it's still by a factor. So it's still by a factor of 1/2. So it's still by a factor of 1/2. What's another fraction? I'm just going to do 2 of them, okay? I'm just going to do 2. I think 2 will be enough. By the way, a has to be what's referred to as a proper fraction. An improper fraction would be greater than 1. A proper fraction is between 0 and 1. So this would be 2/3 absolute value of x. And we'd still call this a vertical shrink. Or a vertical compression by a factor of, but this time we're going to call it what? 2/3. That's supposed to be 1/2 right there. And I'll go ahead and pause. All right, so now that we have this down, let's go over to Desmos real quick. All right, and I want you guys to see that if I have a half right here, I want you to see that it does go up 1 and over 2, and then up 1 and over 2, Up 1. I'm not doing a very good job here, but I'm not too bad. Up 1 and over 2. Over here, if I change it and I make it 2 over 3, all right, 2 over 3, you can do the exact same thing. This time, though, I'm going to go up 2 and over. Let's see if I can do a little bit better job there. That was horrible. Come on, you can do this. There we go. Up 2 over 3. Up 2 over 3. So can you guys see the scale that's happening there? There's the up 2 and over 3. There's the stairs, so to speak. All right? So what can we say about this scale? What's happening between, say, look at the orange function and the blue. Would you say that's more narrow or more wide? What would you say? Is it more narrow or more wide? More wide. So if all these a values are bigger than 1, everything becomes more narrow, then what's going to happen with these guys right here? These are going to become what? Wide. All right? So those factors, those dilations, those scales, okay, those become wider. And that's what you guys are going to be working on today. So what were the 3 concepts that we talked about today? We talked about, first of all, shifting, right? Up and down and left and right. Then we talked about reflecting. Negative f of x reflects across the x-axis. F of negative x reflects across the y-axis. Then we talked about vertical dilations or scaling. If the number is bigger than 1, it becomes more narrow. It's called a vertical stretch. If it's less than 1 but greater than 0, we call it a vertical shrink or a compression, and it makes it wide. And that's all I have to say about that.